Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will be discussing how to write down the distribution of the sample mean and how to use that to find out the confidence interval. But before that, what you need to know is that it's ideal if you know the original population parameters. Let's say you know the expectation of the population, or you know the variance of the population, or you know the probability of the population. But in case if you don't know, you have to use estimates from samples to determine the population parameters. So what you need to know is the expectation of the population can be estimated as the mean of the sample itself. So if you have a small sample and you just calculate its mean, you can take that as the estimate of the population mean. Similarly, if you want to find out the estimate of the probability of the population, what you could do is that you can just take a sample and calculate the proportion of that sample ratio, and that will become the probability of the population. Most importantly, you should recognize the fact that if you do not know the variance of the population and you have to use the data from the sample to estimate the population of the variance, then what you can just simply do is by the formulas that you already know. You already know that you can find out the variance as sigma x minus x bar whole square upon n, or you can find it out as sigma x square upon n minus x bar whole square. These are the formulas you must have learned in S1. So by using these formulas, if you are able to calculate the variance of the sample, then you just need to multiply it by n upon n minus 1. So the unbiased estimate of the population variance is n upon n minus 1 times the sample variance. So if you have a small sample and you're able to calculate the variance of that small sample, multiply that by n upon n minus 1 and you will be able to calculate the unbiased estimate of the population variance. The other thing you need to identify is, again, you should be able to write down the distribution of the sample mean. So if your x, which is the original population, follows normal distribution, then x bar is always supposed to be following a normal distribution. So if x is normally distributed with mean mu and variance sigma square, then x bar should also be following normal distribution with mean mu and variance sigma square over n. But for this particular case, you should be knowing the population of the variance. If n is less than 30, then you cannot use the unbiased estimate of the population variance, and such a situation should not come in your S2 examination. Similarly, if n is bigger than 30, then it does not matter what is the distribution of the population, be it binomial, be it Poisson, be it geometric, or be it uniform distribution. It does not matter. In all of those cases, whatever is the distribution of the original population, sample mean must always follow a normal distribution with mean mu and variance sigma square over n. So next, you should understand what is meant by the confidence interval of the sample mean. So you always found a certain percent of the confidence interval, like an alpha percent, which could be sometimes 90% or 80% or 95%. So, or maybe 98%, but the alpha percent confidence interval means you are looking to find out those values of mean between which the probability of sample mean lying is alpha percent. So a 90% confidence interval means that you get those two values of sample mean between which the sample mean would lie, its probability would be 90%, and so on and so forth. So the process is pretty simple. It's just like a formula that you have to apply. But first of all, you need to understand that if it's like a 90% confidence interval, so that means both tails of the normal distribution have combined 10%. So each tail should have 5%, and hence less than z should be 95%. So for a 10% in confidence interval, you have to take phi inverse of 0.95. Similarly, if you want to find out 95% confidence interval, so that means this area should be 95%. These two tails together should be 5%. Each tail should be 2.5%. So that means Z's less than probability should be 0.975. This is a direct formula. If you want to get to directly what Z value you have to find out, you can just put the value of alpha over here. But I think it's easier to figure out by just identifying that whatever is the confidence interval, you divide the rest of the probability on two tails, and then after finding this tail's probability, you subtract it from 1 and you will get what value of phi inverse you need to take to find out the Z value. And once you get the Z value, this is your formula for the confidence interval. Basically, this formula actually comes from the very original formula that you do, which is Z is equal to X minus mu over sigma. In case of sample mean, it becomes X bar, and this becomes sigma over under root n. So if you rearrange this formula, this is what you're gonna get. X bar equals mu plus minus sigma upon under root n into C. Why plus minus? Because if you're looking for a confidence interval, then you would be looking for two values of X bar, the lower limit and the upper limit. And then once you find out the confidence interval, you write it down in square brackets like this. So this is the lower limit of the confidence interval, and this is the upper limit of the confidence interval. Let's have a look at few examples. A question says the result of a fitness trial in a random variable X, which is normally distributed with mean mu and standard deviation 2.4 square. So I know the original population variance, which will be 2.4 square. A researcher uses the results from a random sample of 90 trials to calculate 98% confidence interval. I don't know mu, but you will see later on that it does not matter. I need to find out the 98% confidence interval. So you would know that this is going to be 98%. The two tails together would be 2% and each tail would be 1%. If you subtract 1%, which is 0.01 from 1, you will get 0.99. So your Z value would be phi inverse of 0.99. And your confidence interval would be mu plus minus Z of phi inverse of 0.99, which is 2.326 times the standard deviation of the sample mean. Original population variance was 2.4 square, so sample means variance would be 2.4 square divided by 90. So you get a confidence interval limits. So a minus will give you a smaller value and the plus will give you larger value. But you need the width of this interval. So that means you do larger value minus the smaller value, and this is where you see that not knowing the value of mu does not matter because mu cancels out and you get yourself the width of the confidence interval because everything else is something you know, and you plug it into the formula and you will get the width. Have a look at another example. So it says there's a time taken t minutes for special anti-rust paint to dry. Was measured for a random sample of 120 painted pieces of metal. So you are taking a sample size of 120, the sample mean was 551.2, and unbiased estimate of the population variance was this. So I mean, if you had a sample and you would calculate its variance, then you would have to apply the formula to get the unbiased estimate. But the question says that it has already found the unbiased estimate for you. So you don't need to do anything to that. You can take this as the population variance. So if mean is 51.2, so you can see that expectation of t is equal to 51.2 and variance of t, this is basically an estimate of the variance of t, and that is coming out to be 37.4. But you want to write down the distribution of t bar. Since it is a large sample size, so therefore the t bar must be always following normal distribution, irrespective of the parent population distribution. So you know that t bar should be following normal distribution, you know its mean, you know its variance, you need to find out the 99% confidence interval. 99% means that each tail will be 0.5% and below z value would be 0.995. So you calculate phi inverse of 0.995 and you learn this formula for the confidence interval 51.2 plus minus z value and then square root of the variance 37.4 divided by 120 the sample size, and you will get the end values of the confidence interval. One more example, it says the results of a memory test is known to be normally distributed with mean mu and standard deviation 1.9. This is about population. We need to have a confidence interval of 95% for mu, and it has to have a width of less than 2. Find the least possible number of tests needed. So we don't know the sample size n. Okay, but since we know that original population is normally distributed, so we would also know that the sample mean should also be following the normal distribution. So if x follows normal distribution with mean mu and variance 1.9 square, then that means that x bar should follow normal distribution with mean mu and variance 1.9 square divided by n. Since I'm talking about 95% confidence interval, so that means center must be 95%, each tail must be 2.5%, and if each tail must be 2.5%, then less than z must be 97.5%, which would be 0.975. So I need to do z as phi inverse of 0.975, and once I get z, I can apply that into the confidence interval formula. I don't know mu, and it matters less because again we are talking about the width, so when we subtract this, the mu will cancel out. And the question says that the width has to be less than 2. So after finding out the difference, calculating the width, I would say there has to be less than 2. I can sort of cross multiply, rearrange the equation and solve it for n. And it's coming out to be 13.9. It is a sample size. It has to be an integer value. It says least possible value since I'm getting greater than 13.9. So the smallest possible value that satisfies this inequality is going to be 14. One more example, and this is an important example because if you look at this question, it says 150, so there's a big sample size, but you don't know the population data. You know the data of the sample. So what you can do is that you can calculate the mean of the sample, you can calculate the variance of the sample, but the mean of the sample would be an unbiased estimate of the population mean. This variance of the sample will not be the unbiased estimate of the population variance. To make it become unbiased estimate, you have to multiply it by n upon n minus 1. Since n is large, so therefore x bar must be following a normal distribution. Variance would be 324 over 150, and once I've estimated these parameters, I write down the distribution of sample mean, and once I write down the distribution of the sample mean, I have to calculate a 94% confidence interval. So central 94% means both tails should be 6%, each tail should be 3%, and I need to find out phi inverse of 0.97. That comes out to be 1.881, and then it's a direct formula pudding, which is mu plus minus z under root a sigma square over n. So I have this sigma square over n, I take the square root of that, I found the z, and I have the mean value. One different thing about this question is that in this particular question, you did not have the population parameters, but you use the sample mean and sample variance to estimate the population mean and population variance. So guys, that's it. I hope it was an informative video for you. If it did help, kindly like this video, subscribe to my channel, and post your suggestions in the comment section. Thank you.